So here is another question on simple harmonic motion. So it is given that a particle executes SHM, simple harmonic motion, on a straight line path. The amplitude of oscillation is 2 centimeters. When the displacement of the particle from the mean position is 1 centimeter, the magnitude of its acceleration is equal to its velocity. Find the time period, maximum velocity and maximum acceleration or SHM. So first, the standard SHM equation format y is equal to a sine omega t. We are writing it simply in this form because no initial phase angle information is given. Here small a is the amplitude, omega is the angular frequency, y is the instantaneous displacement at time t. Then here velocity and acceleration, those parameters are also involved, so we'll also write their equations also. So velocity, displacement with respect to time, derivative, so it is a omega cos omega t. Further simplifying, a omega to the power of 1 minus sine square omega t, because cos omega t we can write it as root over of cos square omega t. Cos square omega t is 1 minus sine square omega t, which is equal to a omega into root over of, here sine omega t we can write as y by a. So here substituting that, it will be y minus 1 minus sine square omega t, which will be equal to y square by a square, this much. So that will be equal to a omega into root over of a square minus y square by a square. That will be equal to a omega into root over of a square minus y square by a. A will get cancelled, so it will be omega, the velocity we can also write it as omega to root over of a square minus y square. These two expressions are important, this one and this one too. Then acceleration. Acceleration is dv by dt, derivative of velocity with respect to time, or second order derivative of the displacement with respect to time. That is equal to minus omega square a sine omega t. So we can write it as, so acceleration is equal to minus omega square a sine omega t. So sine omega t we can write it as y by a. So it will be equal to minus omega square a into y by a will get cancelled, will be minus omega square y. That is the value of acceleration. So these two equations are very important, velocity and acceleration. Now it is given that when the displacement of the particle from the mean position is 1 centimeter, that is at y equals to 1 centimeter, the magnitude of acceleration is equal to its velocity. That is, this velocity equals to omega a square minus y square, okay, which is the velocity. That is equal to acceleration, which is equal to, we are only considering the magnitude, it will be omega square y. So when we substitute the values, it will be omega, okay, here the amplitude of the oscillation a equals to 2, so it is omega into 2 square minus 1 square is equal to omega square into 1. That implies omega to 4 minus 1 is equal to omega square that implies omega here, omega square by omega, it will be omega which is equal to root over of 3 radians per second. This is the value of angular frequency. Okay, here amplitude is given, amplitude of oscillation is 2 centimeter, so A is equal to 2 at y equals to 1 centimeter, when the displacement of the particle from the mean position means instantaneous displacement, y equals to 1 centimeter, velocity is equal to acceleration. So from this we equated these two equations, the magnitude, and we got omega angular frequency is equal to root 3 radians per second. Then we have to calculate the time period. Now we know time period is equal to 2 pi by omega. So it is 2 pi by root 3. So the result that we are getting is 3.63 seconds. 3.63 seconds. Then that is the first thing that is asked. Then the second thing that is asked is the maximum velocity. Vmax, we know that is equal to, for SHM it is omega into A, that is angular frequency and amplitude. Omega is equal to root 3, amplitude is equal to 2 centimeter, that is equal to, it is coming 3.464 centimeters per second. And the third one is the maximum value of acceleration, that is equal to omega square A. So omega is root 3 square into A, amplitude, which is equal to 2. So root 3 square is 3 into 2, that's 6 centimeters per second square. Okay, so this is a very good question. So the thing here which is important is writing the equations of velocity and acceleration in proper form in relation with y, or instantaneous displacement, so that we can substitute the values and equate them. So we wrote the equations in form 1 and 2, and here we equated them. Okay, we equated them substituting the values y equals to 1 centimeter and amplitude equals to 2. Here we substituted the values and we got omega is equal to root 3 radians per second. Okay.